one very important fact that we learn is this. So this is a concept. If I integrate f prime x dx, I will get back my fx function plus c, correct? So when you talk about kinematic, so what is it? When you talk about kinematic, velocity is s prime t, correct? Am I right? So therefore, if I integrate velocity function, okay, which means if I integrate s prime t dt, I will get back my displacement function, right? So that is the first concept that you have to remember, because velocity is rate of change of displacement. That is the first thing. Okay, now if I have the velocity function graph, So for example, my velocity function graph is like that. Okay, for example, it's like that. All right. Okay, and this is a value, maybe I say 1. And this one, maybe I say 2 here. So this is my y equal to vt. Yeah. Okay, so now if I do integrate from 0 to 2, vt dt, this is called change of displacement. Okay, understand? But if I do like that, from 0 to 1, vt dt, plus from 2 to 1, vt dt. Why I have to invert the limit for the second one? Because the area is below the x-axis, below the t-axis, correct? So this is called total distance traveled in the first 2 seconds. Are you clear? So you have to know what is the difference between. So total distance traveled will be area bounded by the curve. If some of the area is above, some of the area is below, then you have to do it separately. Can or not? Okay? Understand? Okay, if you understand that, can we go to example 8 in your textbook? Can you please look at example 8 in your textbook? I'm going to do it a bit differently from your textbook, okay? Example 8. Okay. Let's do example 8. When we want to do example 8, first of all, how far does P travel in the first 4 seconds? Okay, they give you the Vt function as t squared minus 3t plus 2. So this is the VT function. Am I right? Okay, so they want you to find the part A. How far does P travel in the first 4 seconds of the motion? That means we want to find total distance travel. First 4 seconds. Okay, that is what you want. So now we are going to graph the graph of the velocity first, instead of using draw sign diagram. At least you see the graph is clearer to you. So now, can you please key in the function into y1? Can you please? And graph the graph of VT. Take out your graphic calculator and graph it. So that means use your GC. You key into your y1 as x squared minus 3x plus 2. Done? Then you go to your window. Since they talk about first 4 seconds, correct? So we put our x minimum as 0. And x maximum, since it's until 4, maybe we just put 4.2. Just a bit more is good enough. Then after that, we go to zoom. Then you do a zoom fit. Right? You got that? Okay, so now you transfer the graph into your notes. I think the graph looks some sort like this. Am I right? Yeah, so important critical point is here. Can you please find the 2 points using your graphic calculator? I try to minimize your algebraic calculation. Okay, so use your graphic calculator to help you. Is it 1 and 2? Is it 1 and 2? Okay, there's 1 and 2 here, correct? So we want the first 4 seconds. So now you see there are 2 parts of the area above the x-axis, above the t-axis. There's 1 part below the t-axis, correct? So now what you need to do is, you want to find the answer for part A, correct? Based on this graph, you just write integrate from 0 to 1. This one you key into y1. If you are in the exam, you can just denote this as y1. So the examiner will know which function are you talking about. So I will put in y1 dt. You cannot put dx, I have to put dt. Then plus. The second part is below the x-axis, correct? So should I invert that one so that it becomes positive? Yes. Okay, you write down properly. Then plus 2 to 4 y1 dt. Then equal to. Then you key into the calculator, one go, FNINT, key in. That's it. Take your time, relax and key in. Then you get the answer. Okay? You do it this way compared to you do it using your graphic textbook way. It's the same thing. So take out your graphic calculator and try to key in. Okay, so you see it's exactly like what you have in your textbook, 5.67. 67 means 2/3. Okay, so do you get 5.67? So next time, if you see your calculator got 5.67, correct? If they want exact value, correct? You just put 5 and 2/3 meter. You get me? Yeah, 0.67 is 2/3. 666. 2 divided by 3 got 0.6666. Yeah. It cannot, it's not divisible. Yeah. So usually if you want to find that is repeated, correct? You put 66 and you put a dot on top here. That means 6 keep repeating. Yeah. Okay. So like that, you won't find that so difficult like in your textbook. If you count like that, all of you will kill me. Yeah. So just now I sit down here, I say I better teach this way. Yeah. So for part B, I told you already, if you integrate from 0 to 4, that will be the displacement. Am I right? So now you just integrate 0 to 4, y1 dt. So you will get that as a displacement. Understand? Okay. So where is the starting point? The question doesn't give me. So I don't know where is the initial position of the particle. So we put it as C. Are you clear? Okay. So that is the main idea of the whole thing. Can or not? Okay, so if that is done, then exercise 5C.1 and 5C.2 will be yours. So, and 5C.3. Yep. So, now I want everyone to go to question 7 in exercise 5C.2. Question 7. Okay, everyone try now. 5C.2. If the whole area is above the t-axis, correct, then the total distance, this can also be the total distance traveled. Are you clear? Can or not? So that is the first interpretation every one of us must have in mind. Area bounded by the curve of VT represent total distance traveled. That is the first interpretation that we have to remember. Okay, so now let's go to this particular question. So when you want to do part A, the question one, the speed of each animal after 1 second, correct? So for lion, we just write down V11. So you go to your graphic calculator, call out your Y1, put in 1, okay? So you got the velocity. So you just key in 1. So you get the answer as 13.57 meter per second, correct? So you just write down speed is equal to 13.57. Are you clear? If you get negative, you also write as positive when come to speed. So for zebra, you write your V21. Okay, so now you call out your Y2, then you key in 1, and you put enter, you got 1.903. Correct? So you say the speed is 1.903. Okay? So now for part B, I'm going to approach part B in 2 different ways. Okay, first of all, I'm going to approach part B in 2 different ways. Okay, one is by the sign diagram, V1t sign diagram. Because it's an exponential function, so the velocity is always positive. All right, so the acceleration, okay, if you look at the acceleration, when you differentiate this, you will get a negative, correct? Because you have to time by the derivative of the power. A1t is equal to 15 e to the power negative 0.1t times by negative 0.1. So it's always negative. So therefore, speed is always decreasing. Can I not? Okay, for V2, T. Yeah. So this is equal to the sign diagram is also, it will never become, will the velocity become 0? No, correct? So because e to the power of negative is always less than 20. Yeah, okay, so therefore it's always positive also. Right? So for your A2t, okay, so now we get our A2t. If you differentiate, you get 0 minus 20 e to the power negative 0.1t times negative 0.1. So you got positive 2 e to the power negative 0.1t, correct? So this is always greater than 0. Same sign. Therefore, speed always increasing. Are you clear? You can do like that. If you don't want, okay, let me show you by graph. Okay, if you have a graph, one of the graph will go from, how is the graph go? Okay, this is the V1t, right? And this is your V2t. Uh-oh. Your V2t go like that. Right? So what you can say is from the graph itself, you can say from the graph, okay, the velocity for the lion is always greater than 0. You can put in y because the graph is is above the t-axis. Okay, and the gradient of V1t is negative. Is always negative based on the graph. Therefore, the velocity is decreasing. So the speed is decreasing. So for this one, if you use graph, then you have to write more. So same go with the zebra. Are you clear? So I'm not going to write that. Huh? So if you draw graph, then you have to talk more. Okay. If you use sign diagram, then you will talk less because sign diagrams speak for you. Okay. So that will be the part B. Okay. Let's go to part C. Okay. When you talk about part C, since the graph of the lion is always above the t-axis, correct? So therefore, what I can do is for part C, if I integrate from 0 to 3, V1t dt, I can say that this is the total distance. Not all the case, you have to be very careful. Total distance traveled by the lion in the first 3 seconds. So this is the interpretation. So what is the value that you get? Okay. In the first 3 seconds. So this is 38.9 meter. You get me? Okay. So done. Hello. Because the graph, the whole thing is above. So I can say that the lion has traveled 38.9 meter from the starting point, from its starting point in 3 seconds. Okay. Then for part D, and we learn the rules for integration, correct? We have learned the rules of integration. If you have plus and minus, what can you do? You can split it into 2, am I right? So if you see there is a minus, and what is this answer that you get? 13, 30, 30.7 meter. Okay, so now that means how I interpret. Okay, what is the first one? First one is the total distance traveled by the lion in the first 3 seconds, correct? The second one is the total distance traveled by the zebra in the first 3 seconds, correct? So if I minus off and I get positive value, so what can I say? That means in the first 3 seconds, the lion has traveled 30.7 meters further than the zebra. Correct or not? So I will say that in the first 3 seconds, the lion has traveled 30.7 meter longer or further, up to you to say, than the zebra. Am I right? So that means to me, okay, so you see how am I going to interpret? So that is how you interpret this part. Can or not? Hello? Have you written down? Good. So now look, just now this is the straight line. This is the position of the lion. Okay? And this is the position of the zebra. Okay? And just now this is 38.9. That means this one should be 8.2. Am I right? Hello? So that means now it's like that. After 3 seconds, correct? The lion is somewhere here. This is the after 3 seconds. 3 seconds, the lion is here. Where is the zebra? The zebra is from here. You measure another 8.2. Here is the position of the zebra. Has the lion catch up with the zebra? Hey, no. After 3 seconds, the lion still ahead of the zebra. Am I right? Hey, zebra is still ahead of the lion. The zebra is still ahead of the lion. Am I right? Because they start with a different starting point. Got it? So I can also change this question after you calculated this, correct? I will ask you, how far is the zebra ahead of the lion? Has the zebra catch up? Has the lion catch up with the zebra after 3 seconds? So your answer will be no. You illustrate with the diagram. Do you get me? Because they start from the different starting point. Okay, now explain why the lion will be closest to the zebra when V1T equal to V2T. Why? So you have to go back to the graph. Look, for part E, I will go back to the graph. Okay, for part E, this is lion. And this one is the zebra. And this is the intersection point, correct? Am I right? So this one, what is the value? Can someone tell me? 5.596. Okay, then they ask you to explain why after this time, this is a time whereby there is closest. How you explain? You will say that before 5.596 seconds, the lion is travel faster than the zebra. Before 5.596 seconds. But after 5.596 seconds, the lion travels slower than the zebra. So at this point, it is closest. Do you get me? Hello? Get me? So that is explained. So when you go for a race, especially run 400 meters, correct? You don't use up your energy right from the very beginning. That's how you plan. Okay, can or not? Okay, then let's go to part F. So find the time. So we use a graph, we get the time already. So our part F is also done. Part F also done, So it is 5.596 seconds. If they want exact value, then you have to do algebraically lah, huh? Okay, so that one you can try to do it. Okay, did the lion catch the zebra? If not, how close did the lion get? So what you need to do is, you need to repeat this part. Instead of integrate from 0 to 3, now you integrate from 0 to the time whereby they are closest. Can or not? So that means for part G, okay, you say total distance traveled by lion. Okay, you integrate from 0 to 5.596 V1t dt. Okay, then you get the answer. Then total distance. This one we don't have to split because the whole graph is above the t-axis by zebra. Equal to integrate from 0 to 5.596 V2 dt. Okay, then you get the answer. Then we illustrate using the diagram. They will speak the best. Lion, zebra. Here is 40 meters. This is the initial position. Okay, so please use your graphic calculator and get the answer. Joshua, faster. You have to try 0 to 5.596 Y1. Okay, this one is 64.28, right? So this is 40 AD. So 24. So from here to here go 24. So from here to here is 64.28 meter. So this is a new position of the lion. Okay. So for the zebra, I do the same thing, but now I use Y2. So you can just put second interchange Y1 to Y2. Okay, this is 26.20. So from here, I add 26.20, correct? So this will be the new position for the zebra. So does the lion catch up with the zebra? No. So how far away? This is from here to here is 24.28. So the difference is, so the zebra is 26.20, take away 24.28. Yeah, 1.92 meter ahead of the lion, correct? So does the lion catch up with the zebra? The answer is no. That's it. So that is how the application question works. See or not? That means within that time, you make sure that the zebra the lion must travel the difference. You must take away 40. See or not? So that is the logic behind it. So if you cannot see the logic, then you draw the diagram, then you will understand better. Remember, they start from a different starting point. Okay. If you are in SPM, they will ask you to take 1 point as the starting point. I will take the ST as a 0. But this one you go by logic, can it? So are you clear? So this is one of the application in kinematic. Okay, any question? You just minus by yourself. You just minus by yourself. It's 1 point. You take 26.20, you take away 24.28, correct? So here will be 2, here will be 9, and here will be 1. 1.92 meter. So the lion say, hi, just a step more. So close.